My name is Lazar Jeremić, and the name of my paper is Final Verdict of Pressure Vessel with Unacceptable Defect After 27 Years of Exploitation. Before I start this presentation, in this paper we use a risk-based analysis as advice tool to make a structural assessment of the pressure vessels, and also as monitoring tool we use non-destructive testing, conventional, and also we use advice and entity testing. Also parallel with non-destructive testing, we use basic fracture mechanics. Like in this case, we use to calculate stress intensity factor, and also we use failure assessment diagram to make better picture of structure integrity of pressure vessels. In this case, we are talking about pressure vessels in a hydropower plant. The fluid is compression air, and the vessel was installed 45 years ago, and after 8 years of normal operation, during the normal non-destructive testing, we find the defects in our welding joint. And usually, like in every industry, the problem starts when you find some defects in your structure. And usually client come to you to ask the question, what we do if we find the defect in our construction? So you have usually three choices here. Do we leave this defect in the welding joint and continue with operation, or do we need to make some assessment or repairs welding, or maybe we need in some cases to cut the structure and make a new joint? So this is usually the way how we continue. So also the first defects was found with conventional ultrasonic testing, but how the future of NDT testing is continue. Now we have a lot of advanced NDT methods, and also what I can say that we have investigation with Norwegian NDT Society of Non-Destructive Testing, that the advice ultrasonic testing, such as phase array, TOFT, or eddy current array, give 30% better size of defects than conventional. That is why we decide in some stage of the inspection we start to use phase array and TOFT inspection, so that we have better dimensions of our defects in pressure vessel. So this is display of phase array during monitoring. This is S-scan, how NDT inspectors say, and give you more informations about defect in all plates. This is also picture about display of TOFT inspection. So you have all combinations. You have A-scan, you have C-scan, and B-scan of the defects. So you have defects in 3 projection. And also the combination with non-destructive testing, you always use fine element method, how you can see the stress strain in your welding joint. In this case, we decide to make a 3D model of the welding joint, and we look that these defects is crack open to the surface, the most critical situation. So during our fine element method, we use two cases: boundary conditions without y-axis, and also boundary conditions with y-axis. So we have two boundary conditions. We just use different boundary conditions to see how is going to be crack propagations during operation. So this is because on hydropower plant in Serbia we have maybe 10 different pressure vessels. So we have a lot of defects in welding joint, but we decide to present the most critical in this case is pressure vessel with tag number 971, and the first defect was located in the welding joint with conventional UT, and the length of these defects was 180 milli length and deep 30 milli. This is the A scan of the conventional UT. So here is the dimensions of the defect, and echo, the highest echo is here. The base material of the vessel is high straight, low alloyed steel. This steel is not standardized. It is 40 years ago. The commercial name of the base material is Nivoal 50. So after we get informations with conventional, we start with normal monitoring of NDT inspections, visual, ultrasonic every 6 months. And last few years we implement this advice NDT technicians to get better dimensions of the crack. So this is also when we implement phase array and TOFT advice ultrasonic technicians. And what is changed with conventional ultrasonic testing? We have only one defect, but with advice NDT on the same place, we find the first one was the length. We find two defects with length 53.1 milli and deep 60.7 milli, and also second defect with length. This is the second with length 80.8 milli with deep 3.5 milli. So we have now much better picture of location and the size of our defect using phase array and TOFT. And after that, when we find this defect and follow up with NDT, the next step was to make the fine element model. So we make a fine element model, and we have two cases with one boundary conditions only in X axis, and another case we put also boundary conditions in both axes, X and Y axis. So what can we see? That stress, that the stress in both cases was little bit up, where is the yield stress. So in the weld metal, we have in this table that in weld metal we have yield stress around 560 megapascals. So in our fine element calculation, we can see that we have a stress little bit up. In this case was 6.7 megapascal up, and in the second case with two boundary conditions, stress was little bit around 50 megapascals up of the yield stress. And also we can see that we have small plastic deformations in our, this is the first model where we use the only boundary conditions in X axis, and we also have the second one. And based on this fine element calculation in program Abacus, we can see that we have small propagations in the expanding in the length. In the first case, we have total 3 milli in the length. In the second case, it is increasing almost 9 milli. But for integrity of pressure vessel, the most important that we follow up the propagation of the vessel in the dip of thickness. That is, in this case, we don't have so much crack deep propagation. So we can make small conclusion that the integrity of pressure vessels in this case is not still critical. After we complete the fine element method, we start with the basic fracture mechanics calculations. So we start first to calculate for conventional ultrasonic testing. We have informations during inspection 2022, so we calculate stress intensity factor according with the operation pressure, 8.5 megapascals, according with also size of the defect, and also we have a minimal factor toughness before on the old investigations was 1,580 megapascals in millimeters. So after that we calculate the rate, net stress and critical stress, so that we get the epsilon point in the failure assessment diagram. After we finish with calculations for conventional ultrasonic testing, the next step was to calculate also the intensity factor for phase array and TOFT done also during 2022. So we also calculate the stress intensity factor, and after that we also calculate the S coordinate for failure assessment diagram. That was a rate between net and critical stress. So we get 0.2. And after that, all these informations we implement in failure assessment diagram. So based on our calculations, we can see that defect 1.1 find with conventional method is more closer to the potential unsafe zone. So, and also defect find with advanced ultrasonic testing, we can see in the safe zone in the failure assessment diagram. After that, with all these informations, we started with risk analyze. So we use risk matrix and as an advice tool to see where is our pressure vessels or critical equipment in this part. So using these two values from failure and also from conventional and conventional and advice, we also put that our criticality in this case is very high. So coordinate here is 5, and based on previous calculations, we can see the defect find with advice ultrasonic is more safer, but defect find with conventional method is in the critical zone. So after that, we give this fitness for service or this assessment to our client. So the management also decide to finally, after 45 years of exploitation, change these vessels and make the new one. But according with these informations and follow up, these pressure vessels work 27 years with defect in welding joint without any problem during operations. We have small repairs, grinding repairs, and also we have overlay welding repairs with stick welding, basic electrode, but that was also follow up, and the repair welding was successful. So pressure vessels don't have any problems during operations. And this is the final conclusion. The prevention of failures is the almost important for all critical components, like high pressure vessels analyzed here, and also NDT methods is one of the tools that we follow up and and get information about size, and also based on results presents here can conclude that risk-based analysis is a reliable tool in decision-making process to prevent failure of the components with unacceptable defect. Methods based on failure assessment diagram and the new interpretation of the likelihood of failure can be successfully used to estimate the risk of the failure use of damaged components. That was all from my side. Thank you for your attention.